Is that the cone?
Yep. Are you freaking kidding me? Just a little bit.
It's okay.
That's okay. We have some more. Come on now.
Wait, which one did you measure?
Hey now, that was cool. Okay. Hey, that's cool.
Okay, so to answer the first question, which is what is actually causing the can to crush, and to explain it on a molecular level, our answer is that the pressure decreased. The liquid that was started in all three of the cans went to a gas when it was heated up, and then when we forced it inside the ice-cold water, it went back to a liquid, as shown in the orange Kickstart can. When we were pulling it out, water was flowing out, and that is the phase change that it went through. So this is the cause because there was lower pressure inside of the can. When we forced the can with the gas inside of it, the cold ice water made it go through a phase change. So the steam, once hot, is now cold, and it's being sealed off from having the gas escape. And this steam turns cold, and it goes through another phase change, which turns it to a liquid. This went through a phase change because we didn't allow the gas to escape, and we sealed it with the water around it when we had it touch the 0 degrees Celsius water, and we wouldn't let it escape. We wouldn't let the gas molecules escape from it. So it implodes because the space previously taken up by the gas molecules, now going through a phase change, are now being taken up by water molecules. And the gas molecules are no longer there, and that's what causes the implosion, because the space changed, and it's being taken up by water molecules. So, and to answer the second question is, what laws or law is at use or work in this experiment? And Boyle's law is at work in this experiment because we were dealing with volume and pressure. Okay, so the soda can with the largest amount of volume in it was 473, and that was the orange Kickstart can. And then we went down to the Coca-Cola cans, and there was a medium-sized one, which was 355 milliliters, and then the smallest one was 222 milliliters. And Miss Hernus, you tricked us, and we took the water temperature, and it was around 0 degrees Celsius, when we didn't even need it because we were using Boyle's law, and we weren't using any other law. Thanks. Okay, now to the exciting part, which is calculations. And in calculations, we get to find P1, which is the pressure in the can before it imploded. Now, as you can see, I organized volume and pressure, and I wrote all of these down for all three cans before I even started the problem. And after I did that, I did some calculations with the formula itself, and I got P1 equals P2 times V2 divided by V1, and I did that to all three cans. Can 1 is the smallest, can 3 is the largest. So for can 1, P1 equaled 0.99 atmosphere, can 2 equals 0.83 atmosphere, and can 3 equals 0.44 atmosphere. Okay, so earlier in the presentation, I told you that there were phase changes going on in this experiment. So, from a liquid in the can already, when we heated it up, it evaporated into the gas. And when we put it into the cold ice water, the gas condensed back into liquid. Just to make that clear.